Enrico, the floor is yours.
Thanks, Alexander. Alexander already did the presentation, so I'll start with the matter. This is a project that started when an Italian publisher asked a number of authors to design interactive ebooks. Different authors took different approaches, and I choose to write an adventure game ebook. At the beginning, this seemed a difficult task, and we can see now in slide 2. This is a game book. Game books were very popular in the 80s. It was not an original concept, but it was popularized by game books. Game books were regular books printed on paper, which offered choices to the reader, allowing the reader, in a sense, to choose his own, her own narration. In slide 3, we see the first of the two basic mechanisms of game books, which is the branch. The branch, as you can see, simply poses a choice to the reader chooses, and according to the choice is sent to one page or to another page where the narration continues. If I want to do that with an ebook, it's very simple. I use a hyperlink. In slide 4, the situation is slightly more complex. This is the second basic mechanism of game books. I could define it the variables. In this case, the reader has a choice, and according to the choice, to the decision, she has to tick a checkbox or not to tick the checkbox, in this case checkbox C, and go on to the next page. This is something that we have no obvious way to do in a simple hyperlinked environment. In slide 5, we see how this information, which is stored by the reader, by the human reader, in checkbox C, is then read back, retrieved later. Much later, the game book, asks the reader if the checkbox on paper is checked or not, and according to this, sends the human reader to one page or to another page. So we have a storage of information on the left and the retrieval of the same information, in this case a Boolean variable, to the right. In slide 6, we see how this could pose problems in an ebook. We can do the branches because we have hyperlinks, but we have no runtime, no language that could allow us to implement storing and retrieval of the current state of variables. It's true that some devices, some electronic readers for ebooks offer JavaScript or some other language, but there is no standardization. In fact, it's hard enough to have an interactive book, just simply hyperlinked, work fine on different e-readers. Programming would be a lot more difficult. So we have no way to save variables, which is the most important point, no storage, and no processing power. In game books, the processing power was supplied by the human reader. Here, it is not practical. So the only thing that an e-reader can do is remember the current page by setting a bookmark to the page. In fact, we have an immutable set of printed pages, printed in the sense that they cannot be changed, their content cannot be changed. So, what can we do? In slide 7, we see a first way, which is the basis of all complex mechanisms in any book. On this basis, we could build an architecture, a palace. We can represent a Boolean variable by making two copies of the same page, of a set of pages, in this example, of a sequence of pages going from page 2 to page 5. If the reader, the human reader, chooses to, in this case, take the keys of a car in page 1, the link goes to page 2a. If not, it goes to page 2b. This sequence of pages from 2a to 5a and from 2b to 5b could be absolutely identical in content. But when we arrive at page 6, it will have a different effect. Page 6 is different. So we have, in fact, stored the information in page 1 and retrieved the information in page 6. Let's see this from another viewpoint in slide 8. Here I introduce a terminology which is used throughout my program. I call source page the basic page, and instance page it's a copy, not necessarily with the same content. In this case, it has the same content. It's copy which implicitly contains the value of one or more variables, which implicitly contains the state. So I have page 3, which is the source page, and I have two instance pages for page 3, page 3a and page 3b. Page 3a is on the upper path, so it implicitly contains the state keys are false, because that path comes from a decision of a reader to take the keys. Page 3b is another instance of page 3, which implicitly contains the state keys are true. In slide 9, we see the implications, some of the implications of this approach. We can build a behavior as complex as we like by combining variables. We do not need to save information, because the information is implicitly saved into the instance page which we are reading. And the human reader may not be aware of the state, so the author could exploit this in different ways. Our main problem is the combinatorial explosion, because if I have 6 Boolean variables independent from each other, I will have 64 copies, 64 different instance pages for the same source page. Also, a precondition for any book is that the number of possible states must be finite. We cannot have any infinite number of pages. So we cannot have open-ended counters, because we don't have an infinite number of pages to store all the possible states, and no actual randomization. even if a limited randomization could be possible. We see that later. In slide 10, we see that the author had to take care of a page budget. The page budget depends on the medium we are producing for. A printed book can have hundreds of pages, an ebook thousands of pages. After that, the e-reader would crash, I assure you, I tried. The pages here are treated, independent pages are treated by an ebook reader as independent chapters, because if you try to put many pages, hyperlinked pages into a single chapter, you have other problems. We spent a lot of time on e-reader limitations. A variation on a static ebook is a static website, which poses no security problems because there is no code to exploit, and could store millions of pages until we have exhausted the space of a file system throws up. In any case, the author must limit combinatorial explosion. This is not the subject of this talk, it is a related matter. I wrote a small ebook, an ebooklet that talks of this and shows some patterns I discovered while writing my adventure ebook. Of course, this mechanism theoretically allows us to do as we like by multiplying the paths. In practice, doing this by hand is rather hard. So, in slide 11, this is what I did for myself. This is a toolchain that starts with the green icon in the top left corner, that is the book source, which is a Lua program, and produces 6 different output formats, from PDF, EPUB, and so on, from this single book source. What I'm talking about today is the central icon on the first line, which is the Medusa compiler. The rest of the toolchain, for the moment, I'm not publishing. It is also not in a state suitable for publication. In slide 12, we see my adventure book. This is not an advertisement because the book is in Italian, so most of the listeners will have difficulty reading it. At the beginning, I thought it would have been difficult to design good puzzles. In fact, I ended up with puzzles that were too difficult for the average reader. Especially in the first part, I was so excited about being able to emulate a traditional adventure game that I went a bit too far. Then I took better measurements. Anyway, you can do rather complex things where I have an environment that could be explored with items to pick up, people to talk to. In some instances, even multiple characters the reader can switch from, and counters, timers, meant as a number of clicks, and so on. So I wrote about 900 source pages, very small, so pages, do not think of pages of a printed book. And I got from my compiler about 6,000 instance pages and 11,000 links, which would have been a bit difficult to do by hand. To see how I did this, let's go back 15 years to slide 13. This was a very old JavaScript framework I designed for interactive fiction. It allowed authors to write their own interactive tales. Here we see a page with 3 hyperlinks. Of course, there is absolutely nothing difficult in doing this in JavaScript, even 15 years ago. The information is just kept in variables, and it is saved in cookies. So this is not nothing to talk about, but I'm talking about it because I reused the source approach. So let's see in page 14 how a source for this JavaScript environment was structured. The framework was called Idra, that's Hydra in Italian. So Medusa is a descendant. I stay on the mythological. This is a source page written for that framework, for the JavaScript framework. You see that the page is a function, in this case the function kitchen. The author has a few instructions, in this case title, text, and choice. Title and text just print something into the page, into the screen in this case, and choice generates a link, adds a link to the page. We are talking about a JavaScript framework, so we have full programming power of JavaScript runtime. The interesting thing to note is how the choice instructions are structured. The first one prints a link text, get out immediately, and if that link is clicked by the reader, it goes to the page garden. The second choice prints a different text, and if clicked, executes some JavaScript code. In this case, it sets the behaviour variable to 1, and then goes to the page garden too. This is important, and we'll see it again in the Lua program. When a link is clicked, some code is executed. Executing this code changes the state. The state is in the table V, in the object V, speaking on JavaScript, which contains the variables. In slide 15, we see the destination page garden. There is an if instruction that checks a variable from the state, from the current state, which is in the object V. According to the state of this variable, some text can be printed or not printed. So, in terms of the ebook analysis I did before, we have one source page that could generate, in this case, 2 instance pages. One if VBR is 1, and the other if it's not. The good point of this approach is that the author can use just normal programming. There is nothing strange in these instructions. So let's go back to the ebook in slide 16 and see what problems we would have in trying to reuse the same approach from the author's side. The first problem, we have a problem that we have no runtime, so we cannot execute the code. We don't know how to keep track of the state in a way that is manageable by the author, nor how to change the state when a link is clicked. We cannot do anything when a link is clicked. The page is immutable. And how to print a different content, as we just saw in the preceding slide, depending on the current state. But it would be nice to use an approach similar to that of a JavaScript framework. In slide 17, we see a different view of an ebook, of a final ebook, a directed graph made of nodes that are the instance pages connected by hyperlinks. We could, in theory, analyze the source code and try to get this graph. That would be rather hard because the graph has no structure. It could have loops. It usually has loops. And we would have to do a lot of syntactical analysis on the source code. The graph could also be thought of as a state machine where instance pages are the states of our final ebook. So I thought of a much simpler way because I don't like working. So I tried to work as little as possible. In slide 18, we see what I did. First, let's consider that the number of nodes in the graph, the number of instance pages, is a finite number. If it's a finite number, we can, one way or another, we can enumerate these pages and produce them. A simple way to do that is to supply an execution environment that simulates the JavaScript framework we saw before and produces the set of static pages. I'll outline here the algorithm. We'll see it in detail later. I start with a function describing a page, similar to that we saw a couple of slides ago for the JavaScript environment. We'll execute the first page, which is a function, so we'll execute it with the initial environment, initial state. This page will print our first instance page. Then, for each link, we simulate a human reader clicking the link, compute what would have been computed at runtime from the JavaScript environment, JavaScript framework. We'll compute it during compilation. This will change the state. We'll use this new state on the target page and repeat the process recursively. So it may seem a bit complex, but we see the details later. It's just, we see the details very soon. It's just a very simple approach. So much for the theory. Let's see in practice, slide 19. I'll call this a compiler because it translates from a representation to another. In fact, it's not exactly a compiler, it's more, as I said, of a controlled execution environment. Sorry for interruption, I'm just looking at the time. So I skip a couple of details. This is a very primitive software because it was written by my own user. Let's go to slide 20. This is how the author sees the page. This is not only a source page, this is a complete book. The page is named landing. It's a single page, a single source page, that generates 10 instance pages. This page just sets a variable, the count, to 9 the first time it is run, assuming we have a runtime environment for the moment, then if the count has not reached 0 yet, it prints, generates a paragraph, prints the current count, and a link, choice generates a link that, when clicked, executes the code count is count -1. When it reaches 0, it prints we have landed on the moon. So this is Lua code, almost Lua code, similar to the JavaScript code we saw before. So how is this translated into a set of static pages? In this case, 10 static pages. In slide 21, we see the first step. It is modified with a simple textual replacement so that this becomes entirely legal Lua code. The page is a function, and inside the link we see a function. It is identical to what it was before for the rest. In slide 22, the most important data structure in this mechanism is the vtable. The vtable has nothing to do with C++ vtable, means variable table, and is the state of our ebook, the current reading state of our ebook. So, for example, vtable, which I call V, could contain count is 7. Vtables are shallow. I do not allow tables inside vtables just for efficiency reasons. The most important thing to note is that if I have a source page and a vtable, I have an instance page, because the source page will generate a static page representing the state described by that vtable. In slide 23, we see an example. We have a source page landing, which is the only source page we have in our example, and P, which prints a paragraph, prints vcount. If vcount is 7, it prints the paragraph, the HTML paragraph you see in the bottom line, 7 seconds to touchdown. In slide 24, we see the core of a mechanism, the link generation. When the compiler has to generate a page, an instance page, it starts with the source page and the vtable. The link, when it simulates clicking the link, it starts with the current vtable, and it executes the link function inside that environment. So, yes, we see an example soon. This could change the value of a vtable. We are doing a simulation because we have no runtime, so all this is done at compile time. The link, the simulated clicking of a link changes the vtable, and the result is a possibly modified vtable, which together with the target page will generate another instance page. It could be that this instance page already exists. In this case, its name is just reused, or it does not exist. If it does not exist, its source page and vtable are put into a queue for later generation. In slide 25, we see how it works. The compiler is generating a page, and the vtable contains count is 7. It simulates this link. This link contains a function that decrements the count value. So count after the execution of a link function will be 6. The compiler will require an instance page with source page landing, which is the target of a link, and a vtable containing exactly count is 6. And the result, because the page does not exist, the result is that a new request is queued, a new name is generated, and then the name for the instance page, in this case landing _4, is put into the HTML output. In slide 26, we see the last step. When a source page has been scanned and all links have been click simulated, all queued requests are served, and these would probably generate other requests, and so on, until all links have been, until there are no links, or all the queue is empty. At this point, the book is complete. Sorry for the speed. In slide 27, we see the report of a compiler, from the compiler, that sees that we have only one page, one source page landing, that generated 10 instance pages, and for each one shows its vtable, its state. In page 28, we can skip because of the time. Let's go to page 29. This is a slightly more complex example that I put in the distribution. It's the old wolf, goat, and cabbage children puzzle. We have many links, 3 items that could be in 3 different positions. On one side of the river, on the other side of the river, or in the boat. And in slide 30, we see the report from a compiler. Some source pages like start only generate a single instance page, but source page like river generates 20 instance pages, each one with its different state. We see in slide 31 the different states listed in the report for the page river. For example, in river _6, we see, let's see the screen, yeah, cabbage is on the near side, the goat is on the far side, and the wolf is in the boat. I should have used symbolic constants here. In page 32, we see another debugging, powerful debugging option that traces all the states. So by inserting information into the generated HTML page. So we see on top the debugging information is between square brackets, the name of this instance page and its state, its vtable, at the beginning of the page. Beside each one of the links, we see how the state would change, the target page, and how the state would change if that link was clicked. So the state represented by the target instance page. In slide 33, we see a bit of measurements I took on a very old machine. The behavior is almost linear with n, where n is the sum, very roughly, of the number of source pages, instance pages, sorry, and the number of links. It may seem that this is a countdown sample we saw before. It may seem that this sample is very, very simple, but in fact it used to be the worst case with quadratic behavior. I hated that, so this summer I removed it, even if it had no consequences for my book. It happens when a single source page generates a large number of instance pages, because it has to check if each one of these already exists. These times are negligible when compared to only to the time it takes a browser to load the page containing, the HTML page containing all generated pages. And from the time it takes, from the time taken by post-processing, because just opening the file in the operating system takes more time. In slide 34, we see how I used environments. In Lua 5.1, I just used setFenv. In Lua 5.2, I did the textual substitution to add an underline env argument to functions. It's for a variety of reasons, it's not the best solution. I could use different approaches. I could even not use environments at all and just replace the vtable. But I have to preserve cross-page insulation. If one page sets a variable, a global variable, outside of my mechanism, and another page reads it, it would all break. So I have to control, to have a bit of access control. Okay, so I could do that in many ways, probably with a proxy environment. I will see in the future. What's important is that there are so many ways to solve problems in Lua, but the only problem is to choose the best one. In slide 35, we see a possible improvement. Common functions, currently not allowed. Inline pages described by just a line, for example, a page that says, okay, and returns to the previous page. Sub-pages, for example, help pages with a return stack, and the simulation of random choices that could be done by storing some information from previously unrelated choice of a reader, of a human reader. Also, there is a lot of work to do on the code to make this production ready, and much more to make it user ready. In fact, this could be used as a low-level mechanism for a graphical user interface, which would take a lot of work, of course. Let's consider it work in progress. And in the last slide, you see the address where you could download the program from. Okay, so that's all. I thank you for listening, and I would like to especially thank the organizers who spent a lot of time making this possible.
Thank you very much. So, questions?
How do you handle unbounded expansions?
Unbounded values?
Yes, if an expansion...
Well, it's not possible in if I have a fixed number, finite number of printed pages, there's no way I can represent unbounded values.
Yes, but your program can wrongly try to generate an unbounded number of pages. For example, you may have a counter.
Okay.
And so how do you handle that situation?
Okay, as I said, the program is not in a user-ready state because I designed it for myself. I don't remember if I put a limit. Perhaps there is a limit which generates an error if there are too many pages produced. I would have to check the source, But anyway, I thought of that. Probably there is. I should really have to document it.
Okay, next question.
Maybe not such a technical question. Is there any website where such books can be found and where we can play with them?
Unfortunately, the books are in Italian. So if you are interested and you can read Italian, or if you have a good translator, you can reach them from my site, which is at the address shown in the slide.
Okay, thank you.
Then I have a question. Enrico, can you tell us, I know that you said that's outside of the scope of the presentation, but can you tell us, we have 5 minutes, a little bit about how you combat combinatorial explosion?
Okay. Let's see. Let's imagine, for example, that we have a situation, a room with many things. The character, the main character represented by the reader, can do. Switches to turn, books to read, machines, monsters, anyway. Let's suppose that we have 8 Boolean variables. We would have 256 combinations. If the environment is described by 50 pages, each one of these 50 pages would be multiplied by 256, which would be rather inconvenient. One of the patterns is the sequence of environments. I used that extensively in my book. I introduce a bit of limitation in how the actions could be done by the reader, by allowing the reader to do only a few actions, let's say 4 actions. So I multiply the pages by 16. And at this point, the program sets phase is 2. In phase 2, I will have the other 16 combinations. The pages remain identical, so the reader is forced to do one thing before the other, or at least one group of things before another group of things. But the reader does not perceive a change in the environment. So what counts in writing an interactive ebook or any type of interaction is not what really happens behind the scenes. It's what happens behind, in the mind of a reader, within the mind of a reader. So if you can keep up the suspension of incredulity, it all goes well, even if a mechanism is very simple. That's how I designed 2 complex puzzles, because I saw them from the author's viewpoint and not from the reader's viewpoint.
So the smoke and mirrors.
Yeah, exactly.
Okay, the time is almost up. Anyway, so thank you very much once again, Enrico, for an excellent presentation.
Thank you to you for the opportunity.
So, bye-bye.
Bye.